Okay, I was a little too eager to get into these split lines. Looks like it was a bit simpler what we needed to do on part C. I'm going to go ahead and rearrange these two. So I'm going to give myself a column, spin this over here, and then I'm going to use these two now to predict net support, which is what they were expecting us to do instead. And so I'm in the Y range, grab the net support. In the X range, we'll just grab these two columns together. Labels are checked, everything else looks good. And we'll hit this. Okay. So this is where we have both in the model, and essentially what that means is we have parallel regression lines, and that would give us a model where our predicted support was negative 70.0405. There's our constant, or our intercept, plus 0.26875 times the number of months past whatever that was, August 1975, plus 39.6889 times late. In other words, if it's in the early phase, it doesn't get this kind of booster number. And if we are in the late phase, if we're in that second set of points, that value would be 1, and so we would get this boost. So there's a difference of almost 40 of these percentage points in between the early phase line and the late phase lines. We have these parallel lines separated by a distance of 40. Okay, and then for part D, we're conducting a test essentially to see whether or not we should just have the model with only months in it. And notice that the slope would be different if we just have that model with months in there. Once we account for this early late phase, break it into two portions essentially, this slope on months changes, which is very, very normal when you're adding extra variables into a regression model. So we're testing the null hypothesis. The null hypothesis would be that this late phase really doesn't matter at all. In other words, that the slope here would be 0. And the alternative would be that the late phase does have a slope that's non-zero in the population. So we're testing that here. Our t-statistic is 4.16, which would give us a p-value of 0.00095, well below the 0.05 cutoff that we would need to reject the null. So we do indeed reject the null hypothesis and conclude that the slope of the late is significantly different from 0. And what that really tells us, stepping back a bit bigger picture here, is that even though if we look at that model with only months in there, even though our R squared and adjusted R squared we're pretty good at 0.93, this additional benefit that we gain by dividing the points into these two phases, that does make a difference. It makes a significant difference. And we're no longer looking at this now because the model as a whole is probably going to be significant with months in there. We already saw that months is a very powerful predictor. But that addition of late, to see if that was a significant addition, we're looking right here, and indeed it was a significant addition to the predictive power of our model.